So let's take a look at some options for fracturing. Up to now we've just looked at the Voronoi fracture. So let's start from scratch and just get another box. Okay, and what I'll do is first we'll take a look at Voronoi again actually, but a way of making it more interesting. Another scatter, press P to get my parameters. Just do 100 points. Okay, so that's just the same. Let's look at that name attribute just to visualize the pieces a bit better. So yeah, these pieces, you know, they're kind of roundish shapes. So what if we want long shapes? So what you can do is, well, you can control where you're scattering. That's one thing which helps. So you could do that by painting. So a density attribute. So if we get a attribute paint, and just paint the top of the box, maybe give the box some divisions so that we have something to paint onto. Okay, and then paint on the top like that, and maybe on the bottom. Okay, so that will give us a mask attribute. Then I can use that mask attribute here. I should be able to say mask. You can see I get points on the top and on the bottom. And that will give me, you see, smaller, kind of longer shapes. Then if I use that exploded view, go back to that name attributes. Okay, and that gives you, you know, different kind of shapes, longer shapes. Another thing you can do is, if I get rid of that, just turn that off, is to deform your geometry before and after fracturing. So if I grab a transform, scale this lengthwise, or you can see that's kind of equal there. Let's see another way we can do it. Well, if we do a DDB from polygons and fog, that'd be a bit more interesting. Okay, and then once we take this transform and do the reverse, you get, see, kind of something strange. So, you know, you could play around with these transforms. Another thing you can do, maybe an easier way, if we take a rest position there, then deform it. Okay, and then take a wrangle. Just check. I think the rest is on the points, yeah. And then say at P. So take our position is at rest. That should work, I think. Yeah, and then that will take it back. So this way, we don't need to refer to this transform in any way. We can just do something weird here, and it will return back. So we could even drop a mountain in here, and that will be, you know, we get kind of messed up normals, but I think if we append a normal swap after, that might clear them up a bit. Yeah, so there we get interesting thing, but you know, it has its limits. You can see it's kind of breaking there. You know, we need to maybe have less roughness, less height, but you know, you will get more interesting shapes. We start to get kind of bumpy shapes there. So what I prefer to do, this is one option, but I prefer to use booleans. There's this, I prefer to use this new Boolean fracture. Boolean or Boolean, I'm not really sure. I think maybe Boolean is right. Okay, so take that. So this is asking for a cutting surface. So if I just take a grid first of all and plug that in, make this grid a bit smaller maybe. You see, and then the another exploded view. Okay, you can see it's just kind of slicing it. So if I append a mountain here, you can see how we start to get some really interesting results. So this is like a knife, like a slicing. Think of it like a blade or a knife cutting through. Okay. And what else could we do? So, you know, you can get lots of resolution with this. This is the way you can get lots of detail. If I push that up to 50, and then maybe add some noise to this mountain like that, you start to see get some, you know, interesting kind of fractures there. Put that back to default. What I also like to do, so that same kind of workflow of scattering points on your original geometry, be from polygons, get our fog again, scatter, and then definitely have way less points. I'm going to do, I think, 20, and then a copy to points. And then geometry in there, points in here. Before I do this, I just want to demonstrate a kind of, these booleans, they are really good. You get some really nice results, but they can be slower, but also they can be, you know, they can fail quite easily. So if I move this grid over, you'll see what happens there. If any open edge is within your cutting geometry, then it will fail. You can see I've just got the one cuts there with this funny kind of polyline going around it, which is no good. So, you know, we need to make sure, in this case it's easy because we've just got the one line, but that won't always be the case. For example, if I do not that, like that, if I do that, okay, so now I've got loads of pieces, and we may find this could have failed in some places, but maybe not. But it can happen when you do things like this, when you got lots and lots of things overlapping. You know, you might find that one of these grids, you know, if it's copied onto a point on the right, then the open edge can be in the middle somewhere, and it can give you some kind of messy results. So this is a good way of getting loads of fine, nice details. If you use an attribute randomize, a couple of them. One in this case, I would just use one on the normals, do inside sphere. And that will randomize their rotation, you can see, and then you get something like that. A way of avoiding the problem of, you know, intersecting lines is either making these really, really big to start off with, but then you've got, you know, really heavy geometry, maybe cut them down and then subdivide them again after. That's one thing you can do. Another option, which does give you a bit of a different look, is to use a sphere instead of a grid. So if we use a sphere and give it loads of subdivision, same mountain onto that, maybe a bit more again. Okay, and then put that in there, and then maybe use, so, well, we can plug that in as it is. See, it's taking a bit longer now, so it's got more overlapping geometry. So that's kind of weird. We've got big pieces in the middle and loads of smaller chunks around the edge, which is kind of interesting, actually. Not done that. That's a new one for me as well. But another thing you can do, so if we drop another attribute randomize and drop that in here, press escape, so I don't want to go to this, and then randomize the P scale. So then we have different size spheres, and I don't want any spheres which are, you know, infinitely small. Do something like that. Visualize that. There we go. Look at all that detail now. We got loads of really cool, interesting pieces. Obviously, another downfall of this is that we're going to get lots of convex geometry, which, you know, you can resolve by, you know, doing what we looked at in the previous lesson. What I would normally do is split out the bigger pieces, like smaller, tiny pieces. Doesn't really matter if, you know, this is being seen as a convex shape. You're not going to see that in most camera angles. But for the bigger chunks, I would, you know, split them out and do that convex decomposition, or change them into spheres, whatever works. You know, like these kinds of pieces. So that's good. Another option, yet again, for making cool fractured geometry is using our fancy new node called the ABD material fracture. Well, it's not new anymore, I suppose, but fairly new. So I'm going to make this kind of flat like that. Plug this in here. So this is like a HDA built by Side Effects, which just kind of encompasses this and a lot more. with some really handy artist-friendly defaults. So there we got concrete. You know, we can add more layers here. We're scattering points. We're using a volume to randomize where those, a noise in a volume to randomize where those points are. We've got defaults here, so I can set this to glass, so that I've got like an impact in the center. I make this thinner. Well, it doesn't matter, but you know, it makes more sense on a thinner piece of concrete. We can add more impact points. Okay, and then we've got control over how many cracks going around, how many. Let me see. We could do chipping with this, and also with concrete. If I turn on chipping, this is kind of interesting. You see all these kind of thin edges. When that happens, it's the viewport problem here. Press D and go into view and change this to neither, and in this case drop this down to something low like that. So yeah, there's chipping. You can see it kind of chips off the edges like that, which is nice. And then we've got wood as well, which would give you kind of long splintery pieces. This is being clustered. That's why the name attribute is being repeated. But that's kind of interesting. If I go back to concrete, you'll see this detail option. If we go to view, so we can view the edge detail. And you can see it doesn't match up now, but if I turn on the edge detail, see that's now being converted to a Boolean operation, and we're getting these planes cutting into this. So this can be, I find, a bit problematic sometimes. If I push these values too high, I start to get weird results. And let me see if I just push this up really high. It still seems okay. Let me see if I push this lower. There we go. So yeah, after forcing it, you see you start to get weird results. You know, it breaks on a more complex geometry than just a box. You know, that happens much more easily. And you can see here we start to get, so this is a cutting plane coming out into our results. So that's, you know, from me forcing it here, because I've got, you know, kind of ridiculous results, but it does happen more easily with more complex input geometry. But still, you know, it's a good option for, you know, subtle kind of results. We can get interior detail, which will give us noise inside the piece. So we'll kind of add noise, you know, in here as opposed to just along the edge. If I turn that off, we should see the difference. There we go. Okay. So again, you know, we've got, well, maybe not so much here, but, you know, if we push these values, we'll get concave pieces, and we need convex. So if we drop a null, you can see what this does is create proxy geometry for us, and it's set to default. So we can have either convex decomposition or packed spheres. So the default will be just, if we do RBD exploded view, that's a new version of this exploded view, plug that in like that, you'll see it's overlapping. So there we've got our nice geometry with the default, which is just, it's like the Voronoi version of the smooth geometry, which is really good. And you can change that. You can ask for spheres as well. Okay, which doesn't seem to work so well there. You know, you'd have to play around with these values, or the convex decomposition like we used before. This default normally works quite well. Okay, so lots of options, you know, and we've got loads of different constraints we haven't spoken about yet. You know, different kind of attributes that you just have to play around with them to get the results that you're looking for. You can also input your own points here. So impact points for glass, that's kind of handy. If you've got something hitting glass, you can take that location, put it in here. You can use it as a Boolean. So, you know, this could go into here, and we set this to custom, I think, and there we go. I think that's maybe doing it, I'm not sure. And yeah, so you've got lots of options for, let me just set that back to, what do we have? Concrete. There we go. Okay, lots of options for making cool, interesting fracture geometry. Normally for a complex simulation, I'd be using all three. You know, I'd use this for glass and wood. It's kind of this nice kind of pre-built thing. I'd like to use Boleens myself for doing like concrete and rocks and things, and then Voronoi for simple things. So when I'm doing bending metal, we need fracture geometry, but very simple, clean fractures. So I use Voronoi for that. So yeah, there you go.